All right, so today what we're going to do is we're going to talk a little bit about direct variation. Right here I have a couple of ways that you're going to see direct variation. This is the common way we're going to talk about, but this is our usable way that we're going to use a lot of. Now, we've already gone through and done literal equations. So if you recognize this, this is just this solved for k, is all it is, where you divide it by x on both sides. So these two things represent basically the same thing. It's just a matter of which one they're solved for. So we're going to talk a little bit about direct variation, and we're going to go through this fairly quickly. A direct variation is described by an equation of the form y equals kx, where k does not equal 0. The equation y equals kx illustrates a constant rate of change, and k is the constant of variation, also called the constant of proportionality, also known as your slope. Okay, so be aware of when we're talking about the k right here, we're talking about the slope of the line. All right, so you have all these different ways that they represent it, but in all reality, it comes down to the same thing. So don't get bogged down in the terminology here. Understand that they're talking about the constant of proportionality, constant variation. They're talking about slope. So if you can make those connections right there, when you see it, it's not as daunting for you to go through. So, example 1, slope and constant of variation. Name the constant of variation for each equation, then find the slope of the line that passes through each pair of points. All right, notice something. This is what you really need to notice. When we're talking about a direct variation, what that means is that this is proportional. It goes through 0, 0. If it goes through 0, 0, you already have 1 point for your slope, for your line, okay? So that's what you're looking at. Right here, notice, both of these graphs, your line passes through 0, 0. Your line passes through 0, 0. If your line passes through 0, 0 and is linear, straight line, it is a direct variation. It has a constant of proportionality. It has a slope that you can find. If it has that, we get to use this formula, k equals y over x, which means that you can take the y and the x, and you can put the y over the x, and now you know what your slope is, right? So that's what you're looking at, all right? Name the constant variation, then find the slope of the line that passes through each pair of points. Y equals negative 4x, that's that line. Negative 4 is your constant of variation. It's your slope. That's what it's looking at here. And then they go through here and they actually show how they found that, right? 4 minus 0 over negative 1 minus 0. They had their two ordered pairs. Negative 1 comma 4, negative 1 comma 4, and 0, 0, and they plugged it into the slope formula. Once they did that, they found it. Now what I'm telling you is that if you have 0, 0, you can skip this part and you can say, well, let's put x, or y over x, right? 4 over negative 1, and that'll tell me what my slope is. Because if it goes through 0, 0, it's proportional, it's a direct variation, and I know that k equals y over x. If I know that, I can kind of skip this little part right here, make it a little bit easier, a little bit faster for you. All right? So constant of variation is 1/2. Right? Went through 0, 0, y equals 1/2 x. All right? Again, 0, 0, they put the y over the x, 3 over 6, reduces to 1/2. And that's what you're looking at. All right? And that's really what it is. And you can do the same thing over here, right? Name the constant of variation for y equals 1/4 x. Then find the slope of the line that passes through 0, 0 and 4, 1. And I'm telling you, what they're trying to get you to notice is that this k right here is really your slope. That's what they're trying to get you to recognize here. And that you can put 1 over 4 to find that. Now this only works if there's nothing back here behind this x. There's no plus or minus another number back here, okay? It's just this. It's y equals kx. And that's what they're looking at. So the slope, 1/4, right? That's what they're trying to get you to see. And that's what I want you to see, all right? So here, it's the same thing. Graph y equals negative 6x. Write the slope as a ratio. All right, well, negative 6 can be written as negative 6 over 1. So what that means is that you rise negative 6 and you run 1. Fine, no problem. If it's proportional, which it is, that means it goes through 0, 0, 0, 0, and you could start there. 0, 0, go down 6, 1, 2, 3, 4, 5, 6, and over 1. If you have it written out like this, you know it goes through 0, 0, and you know what your slope is, okay? So now you can graph it without any problems, all right? And all of these are basically the same thing, right? And then draw a line containing these points, and you could connect those dots showing it. And notice, arrow keeps going this way, arrow keeps going this way, lets you know that it keeps going both ways, right? And that's all you're really kind of looking at in this sense, what you're going through, okay? Again, y equals kx. The k in this form, because it's a direct variation, don't ask me why they use k instead of m, I don't know, but it doesn't matter because it represents the same thing, all right? All right, and notice, same thing here. Concept summary, direct variation graphs. Direct variation equations are of the form y equals kx. I would also put out here k equals y over x so that you see the slope. The graph of y equals kx always passes through the origin. All right, when you're talking about the direct variation, it's passing through the origins. The slope is positive if k is greater than 0, okay? If you know that if this is greater than 0, you know you have a positive slope. So if you graph it and it's not a positive slope, but this was greater than 0, you have an issue if it goes down. The slope is negative if k is less than 0, so y equals kx. If it's going downward, this is less than 0. All right? Very important. It helps you determine the line without actually graphing the line. Know what's going on with the line. Okay? If the relationship between the values of y and x can be described by a direct variation equation, then we say that y varies directly as x. So this is just a wording thing on what they're talking about. So when you see these word problems that you're going to see, it'll tell you y varies directly as x so that you know that it's a direct variation. So pay attention to the wording on it. Suppose y varies directly as x and y equals 72 when x equals 8. All right, fine. And here's where they're going to show you how that works. Right? Write a direct variation equation that relates x and y equals kx, 72 equals k8, divide by 8. This is where they show you the formula k equals y over x, because you're going to solve for k, divide by 8 on both sides, that gets you 9 equals k, right? And that's the same thing as this. You could put it 72 over 8, and it would still have gotten you the 9. That's what you're looking at there. Okay, so be aware of that. This is really important to understand that this and this are the same thing, and understand how they relate to each other. Okay, this is partly why we talked about literal equations prior to doing this, is so that you have that, right? Therefore, the direct variation equation is y equals 9x, and then they put it back into the direct variation equation, this. So now what you can do is you can plug in x's here, right? Since you know that this is 9, you get to plug in x's here to find out what they are, what the y is, and really be able to graph that line fully out, okay? Use the direct variation equation to find x when y equals 63. They plug 63 in for y, they solve for x. Normally it's the other way around. You have the x, you find the y, but here they gave you the y, you can find the x. So they can give you either one, helps you to find that, okay? All right, so where do we use this? A lot of times where we use this is right here. One of the most common applications of direct variation is the formula d equals r times t. This is distance equals rate times time. right? Distance, D, varies directly as time, T, and the rate, R, is the constant of variation. So the rate is your constant of variation or your slope, your constant proportionality, T is time, D is distance. And you're gonna see this again later on. Like this is the primary way that you're gonna see direct variation is right here, all right? Estimate using direct variation. The distance that a jet travels varies directly as the number of hours it flies. The jet traveled 3,420 miles in 6 hours. Write a direct variation equation for the distance d flown in time t. So distance equals rate times time. So you know the distance, 3,420 miles. You know the time, hours, 6. So you could actually do this and plug this in. 342 equal, or 3,420 equals the rate times 6, the hours. And they set it up. 3420 equals R times 6 divided by 6. The rate is 570 equals R or 570 miles per hour, right? That found that unit rate, that the slope, the constant rate of change, constant of proportionality. Notice all these different ways to say the same thing, right? Just be aware of what you're talking about. And they go through this all the way through and have different ways that they represent this, right? As they go through there, okay? Hot air balloon's height varies directly as the balloon ascend time in minutes, right? And then over here, 350 feet in 5 minutes. Gave you your rate. Find your other stuff. Depends on what they're talking about, right? Okay, so be aware of that. I mean, this is really how you're going to see this represented as we go through there. Let's talk about what your work's going to kind of look like on this. All this stuff really kind of works together. I like a lot of this stuff. I like the distance equals rate times time, the constant of proportionality. But what your real work is going to look like is kind of like this. All right. There is a proportional relationship. So they just told you this is proportional. It goes through 0, 0. That's what's been told to you, right? Between the total cost in dollars, Y, so dollars is Y, and the number of tires Patrick buys, X, he purchased 19 tires for $38. Okay, so you have your X and your Y, 19 and 38. You have your X and your Y. Here's your X, here's your Y. Well, we need to